Yeah, so in manufacturing with composites, we have a variety of issues, dealing from tooling to process design to materials that we have to utilize as well. So composites, we've got the fiber, but we also have the resin to keep in mind. We have a variety of suppliers under that umbrella. So we have to worry about all that, and then we have to put it on either a mandrel or put it in a tool. So we have to worry about tool design and also manufacturing processes that come along with that. And then post-processing, so be it curing, ambient, autoclave, any sort of pressures. And then after that, obviously you're demolding and then you're trimming. So how do you get from the infancy of the design and what the loading conditions are for the composite part, what it interfaces with, be it metallic parts, other composite parts? Do you need adhesives that go between composite parts or metallic parts as well, all the way through to final manufacturing and assembly? Yeah, so for example, the Limec project, we're dealing with a mandrel, so it's on the inside of the part. So we have to be very sensitive to being able to actually release the part from the mandrel. So that limits our like what we can use for tapers and whatnot, because obviously we can't trap the mandrel on the inside. We could do it on the outside, but then it obviously changes the design that we can utilize. We can't use filament winding, for example. We can't wind it on the inside. We have to always wind from the outside on a mandrel. So it does limit us in some respects, but it also liberates us. We can use a variety of techniques. There's a wide breadth of advanced manufacturing techniques these days. And being partnered with the MRC, we're at liberty to utilize some of their in-house techniques in their machines as well. So it's a great partnership that we have to kind of bolsters our composite experience and expertise. My experience with the Canadian bobsled and skeleton teams was great because it was fast turnaround and it was mainly tooling on the cheap. So we weren't manufacturing many parts. So we weren't looking at investing in steel or aluminum tooling. So it was, let's call it garage engineering, just trying to get it done to manufacture one or two to get it out the door. It didn't reduce the part quality by any means, but I learned through all those processes to try to get to the end goal very, very quickly, while not spending a lot of money along the way. So it was a great kind of exercise in how best to limit costs but still maintain quality and performance in the part as well. Oh, it was great to see my parts on the bobsleigh track down in Vancouver. It was great to kind of interface with those athletes leading up to the Vancouver Olympics, and then to see them do very, very well on equipment that I've had a part in and had my hands on. That was quite rewarding. Yeah, and I hope to continue that in the future. Athletes are great in that they're really, really good at what they do, but they're also hyper-focused. So one of the struggles was to kind of put in the process of closing the loop, so to speak, with the athlete, where you give them a product that's improved, possibly, and then getting feedback from them and then integrating that back into the design loop. I found that very, very difficult because the athletes are compartmentalized by the coaches, and they're out doing their own thing or they're on tour. So it was sometimes difficult to kind of get that feedback on improvements that you made, whether it was an improvement or a detractor. But when it did work, it worked very, very well, and we could integrate improvements or suggestions that they had to further improve the product in the next iteration. So.